All right, semester review number 3, surface area and volume. Um, Historically, surface area is one of the hardest things for students out of this semester. There were some of you, a couple, that indicated that that's what you were most concerned about regarding all the topics from this semester in last Friday's poll, but not a ton. And I can tell you that was your lowest scoring quiz, and it is the type of problems which made exam 3 on this material the lowest scoring exam for most of you. So, maybe remote learning and all the stress you've had dealing with circles has made you forget um, about surface area. But I would go back, maybe specifically look at quiz 7 and see, you know, some of the things that happened with surface area, um, so that you can remember some of the mistakes you may have made and not repeat them on this, on this final assessment. Um, Hopefully you have your laminated sheet with you that has all the formulas, all the area formulas on one side, all the volume and surface area formulas on the other side. Now, this particular packet did give you all of these kind of together, um, just a nice little reference in that box on the first page. So you got your surface area formulas, your volume formulas kind of all put into one place. But that laminated sheet is a pretty good reference that you should be able to keep, uh, keep for as long as you need it. Here are some examples, and then you can try these out, and I will put together a solutions video for the main 20 problems um, tomorrow. Example 1 is a sphere, and the surface area of a sphere is 4 pi r squared. The diameter is 12, so we don't want to confuse ourselves into plugging 12 in for the radius, right? You got to pay attention to detail. That's so much of math and life in general is paying attention to detail. If the diameter is 12, the radius would be 6, right? Make sure you follow order of operations. 6 squared is 36. Multiplied by 4 is 144, and then your pi. So that would be your exact answer. And if they did ask you to approximate that, then we're just going to go in and throw in a 3.14 and multiply on our calculators. It's a pretty simple adjustment from that point. Now, one of the biggest mistakes made in volume has to do with this, right here, right? We want to do 4/3 pi r squared because we're so used to using squared for areas of circles and surface area and sectors and everything that we get sucked into believing that it's going to be squared. But this is the volume of a sphere. It has to be 4/3 pi r cubed. If you can avoid that mistake, that's the only variable that exists in this is the radius. So we're going to do 4/3 times pi, 6 cubed. 6 cubed is 216, and fortunately 216 is divisible by 3. So divide by 3, multiply by 4, we get a nice answer of 288 pi cubic feet exactly. Um, it would be multiplied by 3.14 for an approximate value. Next, we have a piece of a hemisphere, right? I guess I'd call this a sector of a hemisphere. We're not going to ask, a uh, surface area problem on this. You could do it, but it would be a little bit tricky. It would be the the 2/3 pi r cubed, but then multiplied by the fraction of the hemisphere, so 280 over 360. Then it would be the pi r squared on the bottom, right? But then multiply that by the 280 over 360 because we only have a sector of that bottom circle. So I guess you could put that together and just say, 3 instead of 3 pi r squared, 3 pi r squared times 280 over 360. But then finally, if you were doing surface area, you would have to deal with a couple extra little sectors here. And these sectors would have a radius of a radius of 24 um, and a angle of 90 degrees, because we're not looking at the 80, we're just looking at this piece of the circle right here, and that's a right angle, isn't it? So that is the those are the sectors. So you could do it, but we're not going to do that. What we're going to do is we're just going to do the volume of a problem like this. The volume of a sphere is 2/3 pi r cubed. But then since we don't have the entire sphere, we'll multiply that by the fraction of the hemisphere that we have, right? So 2/3 pi 24 cubed multiplied by, remember, it's not 80. 80 is what is 80 is what is missing. The volume of what's there would be the remaining degrees going around, which would be 280. 360 minus 80. And then there's just a whole lot of simplification that has to take place. First of all, you want to square, or I'm sorry, cube. You want to cube your 24, so that's going to be a big old number. You could reduce the 280 over 360 to 28 over 36, which would then reduce to 7 over 9, and you could multiply that by your 2/3, and eventually, get, I guess, what, 14 over 27. But then you'd have to multiply that by that 13,824, which was the 24 cubed, and that gives you your final answer of 7,168 pi cubic feet. Problem 3 is a prism. And so if you're going to do the surface area, you could either say, okay, I have 2 triangles plus 3 rectangles, a total of 5 surfaces, and then kind of add them up. Or you could use the textbook problem, which is 2 bases plus the perimeter times the height. Now, be careful, because a lot of people are going to look at this and say, oh yeah, the base is this rectangle down here. But that's not true, because if this really was the base of this shape, there'd be another one up here, and there's not. So that is not the base. The base is actually this triangle, because there is another triangle that's exactly the same. So the height of this prism is actually 11, not the vertical, what we would call the vertical height. By the way, this is a 7, 24, 25 primitive, isn't it? So the vertical height is 7. But now we know that the base is a triangle, which is base times height over 2, and you would get that by doing 24 times 7 divided by 2, and then there'd be 2 of those. It'd be 1 on each side, right? Once again, not the rectangle, that's not the base. The triangle is the base. And then the perimeter would be 24 plus 25 plus 7. And not the perimeter of the bottom. Bottom and base don't always mean the same thing. That's the bottom. The base, remember, is this triangle. So 7 plus 24 plus 25 it would add up to 56. And 56 times the height, which we already talked about, was 11, would give you the answer. All right, so 784 would be what you'd end up with on this problem. As far as the volume goes, we just need to do base times height for a prism. And the base we already talked about is a triangle. Base times height, 24 times 7 divided by 2, right? And then multiplied by the height, 24 times 7 divided by 2 is 84. And then you multiply that by the height, which is 11. And so the work, I think the work up here was for the triangle, which is why it wasn't shown here, because we already showed it. But they did the volume first, and the surface area second. So there's example 3. Example 4. This time we're going to do a pyramid, and it's a trapezoidal pyramid. Because the base is not regular, we would not ask you to find the surface area, because these triangles are each going to be a little different. This triangle right here is going to have a different base and a different height based on a slant height than, say, this triangle right here. And so if all the triangles are going to be the same, because it's a regular based pyramid, then we'll probably have you do surface area, but in this case, just volume. So what is the volume of a pyramid? Well, the volume of a pyramid is base times height. But then because there's only one point we see, right? There's only one point we see, we have to remember to divide by 3. Okay, if there is only one point we see, then we must divide by 3. The base is a trapezoid, so this is where you really got to know your area formulas. Trapezoid is the sum of the bases multiplied by the height of the trapezoid divided by 2. So in this case, the bases of the trapezoid would be 15 and 22, and the height of the trapezoid is 8, multiplied by the height of the pyramid, which they very nicely gave us as 36. And I'm going to go ahead and plug those in. Okay, there's the bases, there's the height, and there's the height of the trapezoid. I like to use little h and big H just so we don't have two h's in the same formula. Don't forget to divide your trapezoid by 2. Don't forget to divide, this is the biggest mistake, your pyramid by 3. People forget to divide pyramids and cones by 3 all the time. On a multiple choice question, that'll always be a distractor, is the right answer except not divided by 3. And so it'll trick you into thinking you got it right if you aren't careful. If you figure this out by following an order of operations, so 15 plus 22 parentheses come first, right? 37 times 8 divided by 2, and then multiply that by 37 and divide everything by 3, you will end up with 1,776, which sounds like a great answer full of liberty or something like that. Number 5, we're back to a sphere, which we know is 4/3 pi r cubed, except this time they give us the volume. They want us to work backwards and find the diameter. Well, I can't find the diameter directly because the volume formula is based on the radius, right? Not on the diameter. So we'll solve for the radius. That's cool. We can do that. So we're going to go ahead and plug in the 972 pi. It's very nice when they give you those pi's in there because that means that you can cancel out those pi's. And then how do you get rid of the 4/3? Probably multiply by 3/4. That's the reciprocal of 4/3. If you wanted to do it in 2 steps, you could multiply by 3 and then divide by 4. But reciprocals are the way to go. Don't take the square root of 729 because that won't undo a cube. You got to take the cube root of 729. And so we end up with 9, but that's not your answer. Because remember they asked for the diameter. Got to double that to get to the diameter. I promise you on a multiple choice question, 9 would be a distractor. And a lot of people would be so happy they got 9, they would circle it or bubble it and move on. Don't do that. Okay, make sure you always know what the question is asking of you. All right, now we've got ourselves a cone, and they tell us the volume is 448 pi. And we know that the volume of a cone is base times height divided by 3, and the base is always a circle, so pi r squared times height divided by 3. It looks like the radius is going to be half of the diameter up here, 16, so half of that would be 8. What I don't know is the height. What is the height? That's the one variable in this equation that I don't know, right? Once again, don't forget those pi's. If they give you a pi, it's probably to make your life easier. And in this case, it does because those pi's are going to cancel. And I'm going to multiply both sides by 3 and then divide by 64, and you get 21 inches for the height. All right, I think this is the last problem. It's a density problem. Remember, density is mass over volume, right? Because you love density, right? You love density. Not remember, draw a heart, draw a line through it, m over v every single time. They gave you the mass up here in this problem. They told you that 2,500 grams is the mass of the object, so we can go ahead and plug that in. But what the heck is the volume of a of an object. They don't even tell us what the object is. Well, we do know that when it's dropped into the cylinder, the water level rises. So, if the water level was originally maybe, this high, and then the object was dropped in and it went up just a little bit. Well, whatever the volume that it just rose was right here, whatever that volume is, has to match the volume of the object. And that's how displacement works. So we know that the volume of a cylinder is pi r squared for base times height, right? But we're not going to multiply by this 12 here because that would give us the volume of the full cylinder. And I don't need the volume of the cylinder. I just want to know how much the volume changed. And so I'm gonna use this 3.5 here for my height. But other than that, it's just pi r squared times height. And because this is an application problem, we're going to use 3.14 as an an approximation. Multiply it out, make sure you square the 8 first, and you get 703.36. And when you divide those numbers, you get 3.55 grams per cubic centimeter. And that's the end of that problem, I believe. Sometimes you'll have to match that up, with a table and figure out what element might have produced that density, but not in this case. So hopefully these 7 problems or examples help you remember some of what we were doing back in, Unit 3, which covered Chapter 12, surface area and volume. Hopefully you have your laminated sheet with all those lovely formulas on them. And hopefully you enjoy the 20 problems that lie ahead, covering surface area and volume and maybe even a couple density problems. Um, the nice thing about these problems is you will know how you're doing almost immediately because check it out. All 20 answers are provided for you in the back of your packet. They're all just right there waiting for you. So check your work as you go, see if your answers are right. If they're not right, try to find your mistake. Might be something simple. Maybe it's 3 times, bigger than it should be. It's because it was a cone or a pyramid and you forgot to divide by 3 for the volume, right? Or maybe it's twice the amount because you accidentally used the diameter when you should have used the radius. There's a lot of simple mistakes, but try to let me know by 8 o'clock tonight what problems you just can't figure out, and I will include them in the solutions video for these other 20 problems. Otherwise, I'll probably just bust through and let you look at some worked out answers for the ones that I have worked out, which are some of them, but not all. So be specific with which problems you'd like me to go over, and good luck reviewing Chapter 12, Surface Area and Volume.